So this is the answer key for the practice problems to help you study for our first quiz on measurement, significant figures, scientific notation, and the metric system and dimensional analysis. So our first couple of questions have to do with measurement and also in terms of uncertainty and significant figures. So you're going to look at your ruler here, which has markings. It doesn't have units, but there are markings at each whole unit as well as in between at each tenth of a unit. So that means that this object is at 1.123. It's between 1.3 and 1.4. Okay, so our reading here is 1.3, and then we have to estimate one additional digit in between the 3 and the 4. So for the purpose of this exercise, I'm going to say it's 1.35, halfway between 0.3 and 0.4. And then the plus or minus, this is another way of showing your significant figures and your estimating. So whenever you're asked to do a plus or minus, what you want to do is plus or minus whatever place is estimated. So I'm estimating the second decimal place, the hundredths. So I'm saying this is plus or minus 100th. So you could say 1.34, 1.36. My estimate is 1.35 plus or minus 100th. So whatever your last decimal place is, that is also the decimal place of your uncertainty, and it's plus or minus 1 in whatever decimal place that is. So here's another example. Two more examples, actually. So the pencil, it's a little blurry because I had to blow this up. But we have centimeters, we have 9 and 10, and then we have the tenths in between. So again, I'm going to go to 9 point, and it looks like it's just beyond the 0.4. So it's 9.4, let's say 2. Again, that last digit is my estimate. It's close to the 9.4. It's a little bit hard to see here if it's 9.2 or 9.3, which again is why we're going to say here plus or minus 1/100th. The plus or minus is whatever your last decimal place was, and you say it's plus or minus 1 of whatever that was. In the cylinder, there's a couple of things here. One, this is also something we'll need to do in our first lab coming up in a few days, is reading on a graduated cylinder where you have this curve, right, where it's the solution is higher on the sides than it is in the middle. This is what's known as the meniscus. It's caused by a combination of surface tension and something called adhesion. So when you're reading graduated cylinder, you want to read at the lowest point, which is just down here in the middle. This is 40 and this is 50 milliliters. And so that means that each one of these marks is 1 milliliter. So this is 41, 2, 3, 4. So the line of the water is between 44 and 45. So I'm going to say that it is 44, and it looks fairly close to the 45. So I'm going to say it's 44.8. And this time, over here, I was estimating at the hundredths. In this case, I can only estimate to the tenths. So my plus or minus is 0.1, 1/10, either way. All right, so counting significant figures, remember the rules are that everything that's not a zero counts as significant. Zeros in between other non-zero digits count as significant. And zeros at the end of a number that has a decimal point are significant, trailing zeros in a number with a decimal point. So for the first number, number 1 here, I have 1, 4, 5. Those are all significant. And then I have a 0 on the end, a trailing 0. However, there is no decimal point anywhere in that number, which means that that 0 is not considered a significant figure. So this only has 3 significant figures. The second number, 53.06, the 0 here, so we have 3 digits that aren't 0, and then the 0 here is between the 3 and the 6, which means it's sandwiched in there. That second rule says zeros between other digits are significant, so all of these digits count as significant figures. And in the last case, we have a decimal point, so that will factor in potentially. I have a 3 and a 2, so those are significant. Then I have to decide what to do with all these zeros. First thing you need to keep in mind, zeros to the left of all the other digits never count as significant. So I can immediately ignore all those zeros on the left. Even though some of them come after the decimal point, they come before the first digit that's not a zero. So those are placeholders, they're not significant. This last zero falls under rule number 3. It is a trailing zero at the end of the number, and there's a decimal point in the number. So therefore, there are 3 significant figures here. Okay, so then we're going to do some calculations and rounding with significant figures. So we need to know the rules for rounding, and remember that they are different depending on whether you're adding, subtracting, multiplying, dividing. So if I were to add these first two numbers together, 5.6 plus 3.26, that would be 8.86. That's the actual full answer. The rules for adding and subtracting say that your answer cannot have a more specific decimal than the numbers that you started with. And another way that I've seen this written is find the least common decimal place, right? So the decimal place that every number has, the last one that they all have, and don't go past it. So this number goes to the tenths, this number goes to the hundredths, so the last place that they both have is the tenths. So that means I'm going to round my answer off to the tenths. So that would be 8.9. In the next question, we're multiplying. So the rule with multiplying and dividing, so the adding and subtracting rule are the same. Multiplying and dividing, you have to take the number with the fewest significant figures overall, regardless of decimal places, and round your answer to that many significant figures. So when I run this calculation, I get 0.01716. That's the full result in the calculator. This number here, remember these zeros to the left are not significant, has 1, 2 significant figures. This has 1, 2, 3. So I have to go with the smaller of the two, which is 2 significant figures. So again, these are not significant. There's 1, 2 significant figures I have to round off there. So my final answer here is 0.17, and I drop the rest of those places. Now the final problem on this example has adding and multiplying. So what do you do when you have 2 different rules and both operations in the same calculation? Here's the way, the best way I've seen it explained. And I'm going to jump to a new slide just to focus on this for a minute. When you have a mixed operation, first things first, don't round until the end. Okay, you always want to keep all your places that you can up to the end and then round off at the end. The question then becomes, how do I know where to round given that I might have adding and subtracting, which has one rule, and multiplying and dividing, which has another rule? So here's the way it's explained. Keep track of each operation and how it would be rounded. Okay, so you know, for example, in this case, we're adding 4.23 and 0.3. Because of the parentheses, the order of operations says I have to do that first. So let's do that. And what we have is, then we have 4.53 times 6.55. So I've done the adding and subtracting. Here's what this means when it says track your significant figures throughout. Because this was adding, I have to look at the decimal places. The last common decimal place between these two numbers is the tenths. So I'm going to put a little line here to remind me that that answer would have been rounded to 4.5 if that was the end of the problem. Now I'm going to look at multiplying these two numbers together. When I multiply them together, I get 29. Oops, go back to black here. 29. Try that again. All right, 29.6715. Okay, so here's where, now we've done all the calculations. So this is the final answer. I've carried all my decimal places through the whole thing. I didn't round anywhere along the way. Now, according to my original calculation, this number should only have 2 significant figures. This number had 3 significant figures. According to the rules for multiplying, which is the thing I did last, I can't have more significant figures than the fewer significant figures in my calculation. So since this number would have had 2 significant figures if I had rounded along the way, that's what I'm going to use and say my answer can only have 2 significant figures, which if I round this, is going to be 30 with the decimal point. The decimal point is there to show that that 0 is a significant digit. Okay, so again, it's complicated when you start mixing the operations, but the answer is keep all your decimal places all the way through, but keep an eye on how many significant figures each number would have if you rounded after each step. And then when you get to the end, use the rule for the last thing you did based on all the rounding that you might have done along the way. And I know that sounds crazy, but it's sort of trying to minimize the amount of rounding you do, but also obey all the rules together. So that's the way we have to do it. All right, scientific notation conversions. Remember that you have to have a coefficient that has one number to the left of the decimal. So I'm going to put my decimal point after the 1 here. In order to do that, I had to move this implied decimal point 1 to 3 times, which means the second part of the scientific notation number is 10 to the 3rd power. In this, I would do 9.73. I had to move the decimal point 1 place, but since I started with a decimal, my exponent is -1. Here I have 1, 2, 3 moves to make it 3.6. Because these were not significant zeros, I can ignore them when I write my scientific notation. 10 to the 3rd power because I had to move 3 times, just like I did in the first example, right? Those were both had digits in the thousands place, so I'm multiplying by 10 to the 3rd. Over here on this side, I'm going to have 5.4 times 10. The exponent is 1, 2, 3, 4 steps, and since it started as a decimal, I make that -4. Here I have 1.47 times 10, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And because it started as a decimal, that's -9. Last one here, I'm going to write 5.26 times 10, and it's 1, 2, 3, 4, 5, 6, 7, 8 steps to get the decimal point there. So that's +8 because it started as a large number. Rewriting the scientific notation into regular notation. The exponent here is 2, so I'm going to have to move the decimal point 2 places to make the number bigger. So it's going to be 680. I moved 2 decimal places. I had to add a 0 to hold the ones place. Here I've got 7.42. So that's 1, 2 places to move the decimal point past the 4 and the 2. The total is 9, so now I need to add 1, 2, 3, 4, 5, 6, 7 zeros. Okay, so that's moving the decimal point 9 times. The first 2 are the 4 and the 2, and then I keep going from there. On the other side here, we have negative exponents, which means I'm going to end up with a decimal. So I'm moving the decimal point to the left. I move it 2 times. 1 is the 7, moves past the 7, and then I move it 1 more time. I have to place a 0 there, so it's 0.07. Again, this 0 is not part of the moving of the decimal point. It's really just there to highlight the fact that there's a decimal point there. If you just wrote 0.07, that would be totally fine. -5 means I move once and then 4 more times, so that's 0, 0, 0, 0. Right, 4 zeros plus move past the 1. The 2 was already after the decimal point, so that's -5, putting it back into standard notation. All right, then the last couple of problems here, calculations with scientific notation. So in scientific notation, remember adding and subtracting, you have to have the exponents match first and then do the calculation. In this case, these exponents don't match. There's a 3 and a 4. So this is 1,000 and this is actually 10,000. So the decimal point wouldn't line up if you just stack these numbers the way they look now. So in order to fix that, I have to move this decimal point over 1, which now makes it 0.8 times 10 to the 4th plus 6.45 times 10 to the 4th. Now that the exponents match, I can simply add these coefficients together, which gives me 7.25 times 10 to the 4th. And if I really wanted to keep an eye on the sig figs, technically this has the tenths as the last common decimal place, so I would write 7.3 times 10 to the 4th. Okay, so it says correct in order of significant figures. If you only wrote this as your final answer, you lose a tiny bit of credit for not correcting the significant figures. All right, subtraction here. In this case, the exponents match, so I can go ahead and just do the math. 9.5 minus 5 leaves me with 4.5 times 10 to the 5th. However, since that is the ones place, my final answer is actually 5 times 10 to the 5th. I have to round it. Okay, multiplication, you multiply your coefficients together. So we would rewrite this just to show you how you would do it sort of by hand here. And then the times 10 is going to be times 10 to the power of -4 plus -7. When you are multiplying, you add the exponents. When you're dividing, you subtract the exponents. So what that comes out to is 4.5008 times 10 to the -10th, which I'm going to round because this has 2 digits. So the rules for multiplying and dividing says you have to round to 2 digits. So it would be 4.5 times 10 to the -10th. And so you might be wondering, wait, if -4 and -7, you add those together, you get -11. That's true. But again, if you use the calculator, some of this will be taken out for you. If you multiply 7.76 times 5.8, you actually get 45.008 times 10 to the -11th. I had to change that by moving the decimal point over, which means then I add 1 to my exponent. So I'm adding 1 to -11. It ends up being -10. So again, calculator is your friend here because it will take care of some of that jostling of the decimal point and the exponents out of the equation, literally. So here, 7.3 times 10 to the -6 times 6.2 times 10 to the 4th. We add them together. We multiply the coefficients, and this is another case where it's really 45.26 times 10 to the -2nd, but I have to adjust that decimal point. I get 44.5 times 10 to the -1. So I move the decimal point 1 to the left. I have to add 1 to the exponent. So this would be the final answer here. Now when we divide, we divide the coefficients and then we subtract the denominator exponent from the numerator. And actually in this case, since we're subtracting a negative, we actually end up making that exponent bigger. So what we would get is 0.157, and then there's a whole bunch of more decimal points after that, times 10 to the times 10 to the 13th, because it's 9 plus 4. Looks like it says plus 3. But because this is a decimal, I can't leave that in my final answer. It's 1.57, and then I have to take 1 away from my exponent because I moved the decimal. It was a decimal. I made it into not a decimal, so I have to subtract 1 from my exponent. So this would be your final answer there. I didn't circle that one up there. Okay. The final couple of questions are dimensional analysis. The first one is a straight metric conversion. The bottle is 1.4 liters. Convert to milliliters. So you need to know the conversion from liters to milliliters, or meters to millimeters, or grams to milligrams is one base unit. A liter is a base unit, is equal to 1,000 milliliters, in this case. Because I started with the liters, I have to put liters on the bottom, the 1,000 goes on the top, which means 1.4 times 1,000 is 1,400 milliliters, because the liters unit cancels out. So anytime you're converting from liters to milliliters, you move the decimal point 3 times, you're multiplying by 1,000, it's the same thing. The second question, how wide is the desk? If it is 0.65 meters wide, I don't have a meters to inches, I need inches. Remember, how wide is the desk? So always look for the question. Well, I've got a conversion here in inches to centimeters, and this is actually backwards. Sorry, I corrected this on the packets and forgot to do it on the sheet. So 1 inch actually equals 2.54 centimeters. That's the way around. Right? A centimeter is about half an inch, is the way it works. Okay, so I've got a conversion from inches to centimeters, so that's good. But my measurement here is in meters, so I'm going to have to convert the meters to centimeters, and then I can convert centimeters to inches. So again, a metric conversion to start. Centimeters, 1 meter is 100 centimeters. So I can convert the meters to centimeters, and then I have the conversion over here of 2.54 centimeters are equal to 1 inch. So that gets me to the inches from the meters. Cross out meters, cross out centimeters. I'm left with inches. And then I multiply across 0.65 times 100, and then divide it by 2.54, and I get 25.59 inches, which if I go back to my original measurement, it had 2 significant figures, so I have to round off to 26 inches as my final answer using significant figures. All right, the last problem is a little more complicated, and it's intentionally a little more complicated, a little bit more of a challenge for this last problem. So what we actually just have here is 2 dimensional analysis problems in one. So it's not, there's no way for me to do all of these conversions in one equation. I'm going to convert each one of these initial measurements into dollars, which is what the final question is, right? How many dollars? That's the question. I have to convert each one of the things that I'm buying into dollars and then add them together. So it's made more complicated because it's really sort of a 2-for-1 here. I'm not expecting you to figure out how to convert them together. So we'll just take it from starting with 15 pounds of propane. So we're going to do the propane. And then we're going to do the liquid nitrogen. That's liquid nitrogen. So I have 15 pounds of propane. I have 7.5 pounds. I'm going to just do these, kind of set them up in parallel, and then we can do the math. Because they're basically the same steps repeated twice with slightly different numbers in between, but the setup is going to be the same for both. I've got pounds. Here I'm given a conversion from pounds to grams, so I'm going to use that. 1 pound, 1 lb is 454 grams. That's the same in both cases. Okay, 454, 1 pound. Okay, so I've converted the pounds to grams. What do I need to do next? Do I have grams anywhere else? Kind of, but not exactly. I have kilograms. So the cost is in kilograms, remember, per kilogram, meaning each kilogram costs a certain amount. So I've converted pounds to grams. Now I need to convert the grams to kilograms. Again, remember, kilo means 1,000 units. So 1 kilogram equals 1,000 grams. And that's true for both. I've got pounds converted to grams, grams converted to kilograms. my price is in kilograms. Remember, the per is the equal sign. So I need to write an equal sign down here. Okay, times 1 kilogram costs for propane. It's $2.03, and for the liquid nitrogen, it's $0.62 per kilogram. All right, I want my answer to be in dollars. For each of these. So pounds, start canceling units down here. Pounds cancels pounds, grams cancels grams, kilograms cancels kilograms. Same setup top and bottom here. So the unit that didn't cancel is the dollars, which is what I want my answer to be over there. So I'm set up correctly with my units. I can multiply and do the math here, or multiply and divide, do the math. So 15 times 454 times 1 times 2.03 across the top gets me, and then divided by 1,000 on the bottom, gets me 13.8243. Again, I'm going to carry through the decimal places, then add, and then round at the end. And down here, 7.5 times 454 times 1 times 0.62 divided by 1,000 on the bottom is 2.1111. Okay, so the price of the propane is almost $14. The price of the nitrogen is a little over $2. We want the total, so now we're simply adding these together, and we get $15.9354. Rules for rounding here would say that way back at the beginning, right, I had a value here with no decimal places. So that means my answer ultimately can't have any decimal places, because the rule for adding and subtracting says you go to the least common decimal place, which is the ones place from our original two numbers. So even though I carried all the different decimal places through here, at the end I kind of have to go back through and find, well, what was my sort of the weakest link in the chain as far as adding and subtracting? It was that number, which has 0 decimal places. So my answer can't have any decimal places. So then my final correctly rounded answer is $16 total. And that is the end of the practice problems. So you need to know your significant figures and measurement, your scientific notation in both directions and with calculations, and the rounding rules for significant figures and calculations, metric conversions, dimensional analysis. All of those things will be on the quiz, and there's some videos for some of these. All the slides that we went through are up in the additional resources portion of Google Classroom, and this video is to help you walk through all the problems that we did here. There's also other videos with some of the other worksheets we've done helping you with some of those problems. All right, you will be able to use a calculator on the test, and any conversions such as pounds to grams will be given to you. I will not give you metric conversions, and I will not give you common conversions like minutes and seconds and hours, those common conversions that you should know. All right, good luck.